We are solving a NEET question from wave optics or physical optics. Both appeared in different exams of 2020. Let us see the first question. What it says is, the two coherent sources of light interfere and produce a fringe pattern on the screen. For the central maximum, the phase difference between the two waves shall be, right? So, if you remember how it happens, from a source like in Young's double slit experiment, light is passed through two small slits, so it comes like waves. I am just drawing only rough diagram. So, from here again the waves gets generated, these two waves get mixed. Depending on how do these waves gets mixed, if these two waves are get mixed in same phase, there will be maximum brightness, that's called constructive interference, and vice versa. So, it is very clear that for central maximum, intensity has to be maximum. We know intensity is directly proportional to square of amplitude. So, one is having an amplitude A1, other one is having an amplitude A2. Then A resultant in the form of a vector will be root of A1 square plus A2 square plus 2 A1 A2 cos theta. Theta is the phase or angle between them. If that theta is 0, cos 0 becomes 1. Then that becomes root of A1 square plus A2 square plus 2 A1 A2, that is A1 plus A2 whole square. Square and root will cancel, and A1 plus A2 is maximum possibility. As the amplitude is maximum, respective intensity also becomes maximum, that becomes a bright spot. Therefore, the phase difference between them has to be equal to 0. That is how we have to solve the problem. Now, look at the next question that we have. In a Young's double slit experiment, if the separation between the two coherent sources is halved, let me draw the diagram for you. What does it mean? The same diagram as I told you. It can be understood that this is source 1, slit 1 and slit 2 who behaves like sources. The distance between the slits is small, that is shown with small d. From them, there is a certain distance where there is a screen. The distance between the screen and the slits is capital D. Then there is a fringe formed on the screen, like I have explained in the previous video. That fringe will have a certain width. The fringe width beta is measured as lambda into capital D by small d. We have derived this in the actual lesson of this physical optics. You can see you can go through the derivation if it is required. Right now I am not deriving it, right? It is given that the separation between the two sources is halved. So, I can write beta 1 by beta 2 in different cases as lambda 1 by lambda 2, capital D1 by capital D2, small d2 by d1, because it is in denominator. Separation between the sources is halved. That means that implies beta 1 by beta 2 equal to d2, he said something like is half, that means d1 by 2. So, in the place of d2 I have to write d1 by 2 by d1. What happens to other sources? Distance between the source and the coherent source is doubled. Distance between the source and the coherent sources. This is the screen, distance between the screen and the coherent sources. This is capital D. This is doubled. That means d2 equal to 2d1. Let us write here. d1 is d, d2 equal to 2d. But the wavelength doesn't changes because he has not changed the light. So, lambda remains the same. Lambda and lambda remains the same. So, beta 1 fringe width 1 by fringe width 2 is dd cancels, lambda cancels, this is also cancels 1 by 2, and this is also another 1 by 2. This 2 comes to the denominator. That implies beta 1 by beta 2 equal to 1 by 4. So, second fringe width is 4 times of the first fringe width. That's the answer for the problem. So these two are the very simple problems given in wave optics, just quite basics, right? This is how we have to solve both of this. Thank you for watching.